All right, so today we're going to be evaluating limits algebraically. So yesterday we talked about what it looks like when we have a graph. So today it's going to look like when we have the function. So remember yesterday when I had a problem like this right here and we try to directly substitute it and we get 0 over 0. So if you get 0 over 0, remember I said that it does not work. So what we need to do is we need to try to factor, multiply by a conjugate, rationalize something in order to try to get it so it's not 0 over 0. If it's like 1 over 0 or 0 over 1, those are fine. It's just when it's 0 over 0 that it does not work. So if you try to direct substitute here, you'd get 0 over 0. So instead, what I'm going to do is I'm going to rewrite it as the factors on the top and the bottom. And so these cancel and create a hole. So I do not care for a limit if there's a hole there. Remember, we want to know what's the y value approaching. So the y value would be approaching, plug in 2 here. So 2 plus 2 equals 4. So when I plug in this one here, I get 1 minus 1. So 0 over 0 again. 0 over 0 means I have to try to simplify. So let me see. I'm just going to do the math. I'm not going to keep writing limit. But technically, you should continue to write limit. So this would be, let's multiply this by x. Common denominator. I'm going to flip the bottom and multiply it. So this is going to become x minus 1 times x. Factor this part. So these cancel. So really, we're going to be finding the limit as x approaches 1 of x over x plus 1. Now I can plug in 1. 1 over 2. So your limit for b is a half. For C, if I plug in 3, I get 0 over 0. Means I have to do something. So in these, we're going to multiply by the conjugate of the bottom. So if you remember, I said if I multiply by a conjugate, I always FOIL out the conjugate, never the top. So I'm just going to do the math, pretend like the limit's not there right now. I don't want to have bad notation, but I also don't really feel like rewriting limit a whole bunch of times. When I FOIL out the bottom, I'm going to get x plus 1, and then that will make it a minus 4 down here. So this becomes x minus 3. So the x minus 3's will cancel. So really, I have the limit as x approaches 3 of square root of x plus 1 plus 2. Plug in 3. Square root of 4 is 2. 2 plus 2 is 4. Okay. So this one, same problem. We're going to get 0 over 0. So this time, though, I'm going to multiply by the conjugate of the top. So again, pretend the limit's not there, so I can just FOIL. So I'm going to get an x squared minus 2. So this is a minus this whole thing. So it becomes minus plus x over the bottom. So I'm going to factor some negative 2 to get 1. Is going to be, I had to mess up somewhere. 2 to get a positive 1. Oh, wait, yeah. That would be a plus 2 and a minus 1. Oh, yeah, I don't know why I was thinking it was the other way around. Sorry. That bell confused me for a second. Actually, these cancel. So really, this question's asking you for your limit as x approaches 1 of x plus 2 over x plus square root of 2 minus x. So I plug in 1 here. I get 3 on top. This would be 1 plus square root of 1 is 2. So 3 halves is our answer. On this one right here, when I factor out my top, I'm not going to put equals because they're not equal. I'm going to say x plus 3, x minus 3. So those will that will cancel with that one. So I'm really looking for the limit as x approaches 3 of x plus 3 over x minus 3. This time I get 6 over 0. This means undefined. So you would say D and E for this one because it's a 0 on bottom. So this one right here, as I'm approaching 1, so this is x plus 1 and x minus 1 on bottom. But when I cancel out the top and the bottom, right here, this is really an absolute value though. So it means it could be positive or it could be negative. So if I would plug in like 1.999, so 1.999 would make, or sorry, 0.99999 would make that a negative. So it'd be negative 1 over that function. And if I plug in, so what I'm thinking in my head is if I plugged in like 0.9 into the absolute value like this, that's a negative number. But if I plugged in 1.01 into it, that'd be a positive value. So I ended up with a positive and negative over 2. So this one's going to be D and E from the two separate sides. All right, and then our last one, and this is what we do a lot in calculus, is we learn how to set this function up right here. Once it's set up, you're just going to FOIL this out and see what happens. So then this is going to be, here's the proper notation. I'm going to write it out good this time. The limit is, and I'm going to FOIL this out in my head. So that's this FOILed minus my x squared all over h. So then what should happen for us is the x squared and negative x squared cancel, and I'm going to factor out an h for us. So the limit as h approaches 0, so factor out one of those h's. Now these two h's can cancel, and now when I plug in 0 for h, it does not make 0 anymore. So that's going to give me my limit equals 2x. So you can read through the summaries of this stuff right here. It's everything that we just did, but you need to read it. This is what you should try. You should try direct substitution. See if the limit from each side is the same. If it's a piecewise, if it's a number over 0, it's D and E. 0 over 0, you have to try to factor, rationalize, simplify complex fractions, factoring, whatever. And if all else fails, you can always go back. What I did up here was to make a chart where I was thinking of what happens at 0.999 and what happens at 1.01, and I compared the two answers.